Last 2 days we spent on right triangles, drawing in their altitude, using the parts of the right triangles to solve for other parts of right triangles, setting up proportions, finding the geometric mean, and solving. Today we're moving on to trig ratios. This chapter is entitled Right Triangles and Trig. So today we're moving on to trig ratios. This is some of the simpler stuff that if you would move on to eventually take trig, you would be doing. We're going to focus on one specific trig ratio today, and that's tangent. There's two more, there's sine and cosine. We're going to talk about all three, but when we do problems, we're going to only focus on the tangent problems today. So find the sine, cosine, and tangent of an acute angle, and use trigonometric ratios to find side lengths in right triangles and to solve real-world problems. And this is still standard G8. So, very important. And what I want you to do is copy the notes as I do them first. Then we'll do this on your calculators. First thing we need to do, before we can do any type of problem that involves trig ratios, we need to change the settings of our calculators. So if it's not already, the first thing you do is to turn the calculator on. I know, blows your minds, right? So, second thing we do is push the mode button. And then third thing, we push the down arrow 2 times. The down arrow, the arrow keys that are in blue. Then we're going to push the right arrow key just once. And then we're going to hit the enter button. Okay, now, okay, so if you look up on the board, I have your same version. So, I have to turn mine on. Mine's turned off over time. Okay, now, mode. Now, yours probably looks a little bit different. You have everything labeled. If the last class did what they were supposed to, everything should be dark along the left-hand side. So we press the down button twice to go to the line that says radian degree. We push the right arrow key to label degree, and then we press enter. And when it's dark and blinking, that means that you've set this up correctly. Your calculator's now in degrees. So to get out of that, you can either hit clear or you can hit second quit, and it goes back to the main screen. Why is it important for us to know that? Well, every day, what we're going to do at the beginning of every class is we're going to go through to set up our calculator into degrees. At the end of class, we're going to reset all the calculators so that the next day we have to do the same thing over again. And this is getting you in the practice of knowing that as soon as you get to your SOL exam, you're going to have to take your calculator and put it into degrees. Because the default setting for your calculator is radians. And we clear the memory on every calculator before you take an SOL exam. Okay, just to make sure you guys don't hide anything in the programming or anything like that that would give you answers, we have to clear the memory. So that means that when we clear the memory in the default settings, the calculator is going to default back to radians. If it's in radians, though, your calculator will not correctly solve trig ratios. It will still solve them, but you won't get the right answer. So when you go to the SOL, the very first thing you're going to want to do is put your calculator back into degrees. So, before we start with this lesson, a couple things I want to tell you or remind you of. We can only use trig ratios, just like Pythagorean's theorem that we've talked about, just like the special right triangles. We can only use trig ratios for right triangles. So these right triangles have two acute angles that are not special. Okay, remember we talked about two special types of right triangles. One was 45, 45, 90. One was 30, 60, 90. And we talked about special formulas that helped us solve for those missing sides. We could use trig ratios, but you don't have to in order to solve those. Those we have the formulas that we just plug in and solve. We're going to use trig ratios for triangles such as maybe 20, 70, 90. Or it might be something like 12, 78, 90. Any other type of right triangle, meaning that the 90-degree angles would have to be in there, because 90 degrees is a right angle, and the acute angles would add up to be 90 degrees. This talks about any other type of right triangle. So the ratios then allow us to find each side of the triangle. So we're talking the short leg, the long leg, and or the hypotenuse. If we know one of those sides and we know one of the angles other than 90 degrees, we can solve for the other sides of every triangle. And we always need to make sure, again, real important, we always need to make sure that our calculators are in degrees. Okay, so this, I know this diagram didn't copy great into your notes. It's kind of small. This diagram is in your book on page 525. That way it's also color-coded if you look at it too. In the case of your note sheets that we've done, they don't print in color, so I can't do that. We'll come back to this in a little while. The next slide will deal more with this. Important thing that we want to know right now. Kind of like yesterday when we were doing right triangles, we solved the information that we were given, the important information, either the altitude or one of the legs. In this case, when we see something we're going to solve with the trig ratio, we're going to circle the angle, the acute angle that we're given or that we're asked to find. So if a triangle's drawn and one of the angles are labeled 40 and we have a 90-degree label drawn, we're going to circle that 40 degrees. Then we're going to, based on what we circled, we're going to label the triangle with some specific information. And we'll get to how to do that and what that information here in a couple slides. So circle the angle that we're given or asked to solve for and label the rest of the triangle appropriately. So let's talk about a couple mnemonics that help us remember trig ratios. So first of all, we're going to label the trig ratios. The first trig ratio we have is called sine. And on your calculator, the button's abbreviated SIN. And we're trying to solve a triangle using sine. We're going to use the opposite side of the triangle. So the opposite side from the angle over the hypotenuse. So sine equals opposite over hypotenuse. The second type of trig ratio we have is cosine, which on your calculators is abbreviated COS. This one is the adjacent leg over the hypotenuse. So now we have sine equals opposite over hypotenuse. We have cosine equals adjacent over hypotenuse. And the last one we have that we're going to talk about today is tangent, which on your calculators is abbreviated TAN or tan. And just borrowing the O and the A from up here, this becomes opposite over adjacent. Okay, now, how many of you have ever used the mnemonic? Maybe you didn't know what this is called, but to remember the names of the 5 Great Lakes, you remember the word Holmes. At least one person. Okay? You've used mnemonics before. The Great Lakes, Holmes, Huron, Erie, Michigan, Huron, Ontario, Michigan, Erie, and Superior. That's always a mnemonic that I learned to remember the names of the Great Lakes. Maybe it's because I live closer to the Great Lakes that there was more emphasis put on that where I'm from. But that was always something that we learned to remember the Great Lakes. One that we can use to remember this is called SOHCAHTOA. So if you just like making abbreviations and creating a word out of the abbreviation, this one would become SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Just write it in just like the original slide was filled in for you. Okay? So you can remember the word SOHCAHTOA. When I was in high school in geometry class, this is what my geometry teacher taught me. Then when I got to college, I learned another mnemonic, which was some old horse, caught. I learned caught a horse, but I've also been told from Miss Burnett she learned caught another horse. So whichever way you want to remember it. Caught another horse taking oats away. So this is putting SOHCAHTOA into a sentence. Kind of like you may have learned, and you guys probably didn't grow up knowing 9 planets like I did, but when I was growing up there was 9 planets in the solar system, and to name them from closest to the sun till farther away, we used the sentence, my very entertaining mother just served us 9 pickles. The word 9 was used because 1, it was an N, and 2, there was 9 planets. But it also helped us remember that my stood for Mercury, which was the closest planet to the sun, and V stood for Venus, all the way through. So that was another mnemonic that we learned. So this is putting it in sentence form. So if you can't necessarily remember SOHCAHTOA, but you might be able to remember some old horse caught another horse taking oats away. So is that like that, my dear Aunt Sally thing? Yeah, please excuse my dear Aunt Sally for orders of operations. Okay, now, these mnemonics are going to help us remember, help us tell, based on the information we're given, which trigonometric ratio, sine, cosine, or tangent, that we're going to use in order to solve for the other parts of the triangle. Okay, so get used to one of the three that I've taught you, so that when it comes time and I give you a triangle and I ask you to tell me which trigonometric ratio you use to solve it, and then to solve it, you're able to tell just based on the information. So, on this first slide, this wants us to find trig ratios. And all this is, and we're going to use tangent today, so it says write each tangent ratio as a fraction. All we're going to do is set up a ratio. So we're going to tangent equals opposite over adjacent. We're going to set up that opposite over adjacent ratio. We're going to express it as a fraction, which is what we do when we write a ratio anyway. And then we're going to convert that fraction into a decimal, rounded to the nearest hundredth. How many decimal places is hundredths? 2. 2. Okay, hundredth. Decimal places is tenths, hundredths. There is no one-th place in decimals. So, in A, we're going to take a look at angle A. Going to take a look at angle A. Now, I told you the first thing that we do in order to set up a trig ratio is to circle the angle that we're given or asked to find. For all purposes of 8-2, we're going to be circling the angle that's given. Later on, we'll deal with using sides to solve for the angle. So in this one, we're going to focus, and this said to use tangent ratio. We're going to find the tangent of A. And we just talked that tangent equals TOA. T equals O over A. Okay, so first step was to circle the angle that we're given. The second step I told you is that now we're going to appropriately label the triangle. So if this is a right angle, what is side AB? When we were dealing with Pythagorean's theorem. Yeah, it was the C part or the hypotenuse. So we're going to label this as the hypotenuse. Now, the word opposite means across from. We've been dealing with opposite for a while now. When we were dealing with isosceles triangles, we said that the opposite angle directly corresponded to the side. So here, for opposite, we're going to look at the side that's across from the angle, or the side that doesn't touch this part of the angle. Where the angle meets the vertex, this side, BC, has nothing to do with angle A. So this is the opposite side, which leaves adjacent, which is this part here. And what adjacent means, we talked about this a little bit with the last lesson. Adjacent means the leg of the triangle that touches the vertex. So this angle is a part of this leg right here. So that's the adjacent side. So now we just take a look at and plug in what we know. So the opposite side is 5. The adjacent side is 12. So our ratio is 5 over 12. Well, it is it for the ratio, but it tells us to find it as a fraction and as a decimal. So how do we find the decimal form of 5 over 12? 5 divided by 12, which is rounded to the nearest hundredth. 0.4. I need one more place. So the 6 rounds the 1 up to 2. So this is my entire answer. If it asks for it in fraction and decimal form, you need both answers. Adjacent, ADJ. The adjacent side, ADJ. For part B, I want to take a look at angle E. So that's the angle I'm going to look at. So in this one, just like up here, it was the tangent of the angle A. This is going to be tangent of angle E. Okay, now before I can fill in all this other stuff, I want to label the triangle. I want you guys to get in the mode of labeling the triangles because it will help you, I promise. It is a little extra step that you have to do, but just like yesterday where we colored the triangles that we were looking at, this will help you visualize the information that you need. So if this is the angle, and this is a right angle here, what is side EF? Is EF adjacent? Yeah. Yes. EF is adjacent. It's the leg of the triangle that touches the angle that we're talking about. 24 would be the opposite. It's the one that does not touch the angle. 25 would be representative of the hypotenuse. So what information don't we need here? Sokotoa, do we need the adjacent side? Do we need the opposite side? Do we need the hypotenuse? No, so we're not going to deal with this. Okay, so tangent equals O. So what am I going to fill in for O? 24. And A is going to be 27. What if this gives us like a alpha? It is 24 divided by 7. 3.43. I was going to say the 2 should round up to a 3. So this is our entire answer for this one. If it doesn't say round, it'll always tell you to round because most of the time it's not going to come out to a whole answer. Okay, so our last one. We're going to come back down here and say we're going to look for angle X. So in this one, we're looking for the tangent of X. It'll have it labeled for you. I'm labeling them now, but the book will have it labeled. The acute angle, so the one that's not 90 degrees. Okay, we're never going to use the 90-degree angle to solve trig ratios, at least in here. Okay, so let's label the triangle. What does that make side XY? Not hypothesis. This isn't science class. Hypotenuse. What does that make side YZ? Opposite. Which means that 60 is adjacent. And I'm going to write it above because I keep writing over top of it and then can't read it. So what ratio would I use? What? 11 over 60. Opposite over adjacent. So it's 11 over 60. And what is 11 over 60 as a decimal? So 0.18. Okay, too difficult so far? No. Okay, now I'm going to blow your minds and make this even easier. What we see up on the board, calculating trig ratios. Use your calculator to find each trig ratio. Round your answer to the nearest hundredth, so 2 decimal places. Plug into your calculator tangent 82. TAN. I would get in the mode of closing the parentheses because sometimes it will affect it. So tangent 82 degrees. So let me pull up my calculator here. Shh. Okay. So tangent. Oops, I need to turn it back on. Mine really. Okay. So tangent button's right here. 82. You don't have to put the degree symbol in there because we changed the calculator to degrees. It's now reading that 82 as a degree. And we hit enter. So we get 7.115. That 5 rounds the 1 up to a 2. So this answer is 7.12. So plug in your calculator, tan times 11, close parenthesis. What do we get? So 0.194 just rounds to 0.19. And tan of 65 degrees. 2.1. What number comes after the 4? Is it 2.144? It has to be an acute angle. So we don't want to circle the 90-degree angle. Guys, we were doing so well before lunch. So, B would be adjacent. BC would be opposite. Please. Which information do we not use in tangent? Hypotenuse. Because here we have the angle. We're given the opposite side. We're asked to find the adjacent. So we're not going to use the hypotenuse, which means we're going to use a trig ratio. Tangent. Before we were writing tangent of A. In this one, we actually know the angle measure. So this one's going to be tangent of 41 degrees. We write that equal to the tangent ratio, which is opposite over adjacent. So what is the opposite side? 6.1. 6.1 inches. The adjacent side, no, it's 6.1. Sorry, my board orientation is off. So it's 6.1 inches. The adjacent side is side B. Okay, now, we could go through all the steps of how we solve for B since B is in the denominator. and it would make this problem kind of lengthy. I'm going to teach you a shortcut. If you're asked to solve for the denominator of your ratio, we're going to flip the denominator and the tangent of the angle. So we'd rewrite it like this. This now becomes B. 6.1 inches is still in the top. And in the bottom, it's now tangent of 41 degrees. Okay, so our problem now says 6.1 divided by tangent of 41 degrees. So if we go to our calculator, okay, we're going to go back into our calculator. We're going to type in 6.1 divided by tangent times 41. Hit enter, and we get 7.017, which to round to the nearest hundredth is 7.02. And our label would be inches. So side B is 7.02 inches long. You have to write it like this because this is how the ratio is originally written. Then you can just switch it. Okay? Like I said, I could show you how you get that they end up switched, but in the end, all I want you to know is that they end up switched. You don't have to memorize them because they are on your SOL formula sheet. Not in this form. It doesn't say S equals O over H, C equals A over H, T equals O over H, or O over A. But it does give you the sides of the triangle and shows you how to set them up. But you're going to have to know how to solve them. Okay, so letter B. What angle are we given? We are given angle B, which is 51 degrees. Now we need to label our triangle. What is side BC? Adjacent. What side AC? Opposite. What side AB? Hypotenuse.
What makes that adjacent?
The fact that it's the leg of the triangle that touches the angle we're talking about. That touches the angle that you have or that you know. Okay, because notice that because we're trying to solve for this angle now, this triangle is not set up the same way the other triangle was. The hypotenuse is still the same. That always was. We're not given any information about the hypotenuse, so we're not going to use it. So that tells us that we're going to use tangent because we're solving for the adjacent and we're given the opposite. So we have tangent. In this one, we know that it's 51 degrees. Equals, what's the opposite side? 17. And the adjacent side, we said, let represent the letter A. It's like we did in the problem before. We're trying to solve for the denominator, so we can switch tangent of 51 degrees in A. So we get A equals 17 divided by the tangent of 51 degrees. And what do you get when you plug that into your calculator? So 13.766. That third 6 rounds the second 6 up to a 7. And our label would be meters. If it requires a label, you should label it. On the homework that you guys turned in yesterday, the first 4 Pythagorean theorem questions all had labels. And so far, all the papers that I've graded, no one has used labels. So if it needs a label, you need to put it on there. I'm going to ask you to change some information, only because I want to do a problem that's a little bit different than these two. I'm going to ask you to cross out 12 feet and write a question mark. And in for this question mark, you can write 12 feet. So we're just going to flip the two of them. So in letter C, what angle are we solving for? Or what angle do we know? A. Not angle 18, angle A. Okay, so that's the angle we're going to circle. Now let's label our triangle. What's side AB? Hypotenuse. What's side BC? Opposite. Notice that it's the leg of the triangle that does not touch the angle. So that would make AC what? Adjacent. It does touch the angle here. So, we have tangent. What am I going to fill in for my degree? 18. Tangent of 18 degrees equals, what's the O? What's the opposite side? It's a question mark. So you could choose a variable to represent that question mark, or I'm going to put BC in there to represent that it's side BC. And that's divided by the adjacent side, which is 12. So this looks a little bit different. In this case, we were solving for the denominator. In this case, we're solving for the numerator. So what do we normally do whenever we see a problem like this? We don't do anything with the 18. We need to get rid of the denominator, so we multiply both sides by 12. You don't have to show that. I'll just tell you, draw an arrow to move the 12 up there. So now you have 12 times the tangent of 18 degrees equals BC. So when we plug that in the calculator, we get BC equals what? And this time you can just type 12 tan 18 close parentheses. 3.899, which rounds up to 3.90, or you can just show 3.9, and our label here was feet. So our answer to this one is 3.9 feet. Okay, like I said, the problems we're going to do today are going to be pretty straightforward. They're going to tell you what you need to solve for, or you're always going to use tangent to solve for what they give you. But do get in the mode of labeling these, because starting tomorrow, we're going to have to take a look at what information we're given and what information we're trying to solve for in order to figure out which trig ratio we're using to solve. So do get in the habit of labeling these. Is there any questions on this? Classwork to be done and turned in by the end of class. 529, 530, this was on the board when you came in, all those problems. Now, they are out of order, but they're out of order for a reason. In the book, in the problem section, the problems, I grouped them together so that you're solving all the like problems together rather than solving a couple where we set up the ratios and find out the decimal equivalent, than doing a couple where we type in tangent times the angle and fill in the decimal, and then do a triangle and then go back and do it all over again. I grouped the problems together. So do them in this order, and they go in the order, they're grouped in the order that we did your notes. Then, when you get started, I'm going to pass out assignment number 2. This is the assignment that we give on typically a Wednesday, but I'm giving it out today since we didn't have any problems to do on it last night. I'm giving it to you today. It'll be due next Wednesday. The tangent ratios are problems 17 through 24. So we're going to be doing the last set of problems on the worksheet rather than the first set. And your notebooks are lesson 7.3 and 7.4.